Hello. As many of you have not had a chance to meet me, I thought I would take a moment to introduce myself. My name is Jasmine Lee and I am a postdoctoral researcher at Monash University here in Melbourne. I completed my PhD at the University of Queensland in Brisbane and is all about conserving terrestrial Antarctic biodiversity in this era of massive global change. Today, I will introduce you to the Systematic Conservation Planning project and guide you through the steps needed for the stakeholder engagement. Thank you very much for giving up your valuable time and contributions to assist in the project and to help the Antarctic Peninsula.
Hello, biodiversity, science and policy experts. I will now be giving you a background on the project and explaining why it's important, and also explaining the basics of systematic conservation planning. The project is a collaboration between SCA and IATO, the International Association of Antarctica Tour Operators. And it is being carried out at Monash University, where I am based and where Stephen Chown, the PI of the project, is based. Justine Shaw and Alex Terords are also a part of the project team, and we have a fantastic coordination group at SCA and a liaison group, many of you whom are listening now. So, why is this project needed? Well, as many of us already know, the Antarctic Peninsula is rapidly changing with climate. Human activity is also growing quickly, and that is both science and tourism. There's also quite a bit of questioning and pressure from Antarctic treaty parties about how to better manage human activity in the region, particularly with the rapid growth of tourism. So what changes do we expect to see in the Antarctic Peninsula now and into the future? Well, as probably most of us know, the Antarctic Peninsula is the most rapidly warming site in the Southern Hemisphere. And so we're kind of seeing changes already. Moss beds are expanding, some species are moving south, and even earlier this year we had record high temperatures. So Marambino Station reported temperatures of over 20.3 degrees, which is very high. And this is kind of the things we might start to see into the future, as well as increased precipitation and liquid rain. And of course, that's just the direct impacts of climate change. There's many other indirect impacts as well. One of those, of course, being invasive species, which are one of the greatest threats to Antarctic biodiversity and are expected to increase with climate change. So this slide shows the suitability of ice-free areas for establishment of non-native species. So in blue are ice-free areas that are not suitable, and in red it's where we expect establishment to be possible. So on the left is ice-free areas today. There's not that many kind of red spots. But on the right, at the end of the century, with climate change, we expect there to be quite a lot more. And then we have human activity. So both science and tourism is starting to grow not only in the peninsula, but also elsewhere in the continent. But it's of particular concern in the peninsula due to the climate change impacts and also the rapid growth. So tourism has been growing in Antarctica since the late 1990s. It is primarily concentrated in the peninsula because this is the most accessible part of the continent. If you're wondering why there's a bit of a dip before 2010, that's because of the global financial crisis. But as you can see, tourism has recovered since then and has been growing quite rapidly in recent years. And it's not just tourism that's growing, but science activity is also increasing around the continent. So this map shows scientific facilities or stations across the continent. Those in green were built prior to 2000 and those in blue afterwards. And today there are new stations or facilities or camps proposed almost every year. So what are the potential impacts of human activity? Wildlife disturbance is an easy one, so that's from both vehicles and people. Trampling of vegetation, disturbance of soils and old surfaces. This is particularly a problem in places like the dry valleys, but also around landing sites in the peninsula. Pollution is an obvious one, and one that might not come to mind straight away but is really important is actually increasing transport of invasive species to get to Antarctica. So humans are the primary vector for taking invasive species to the continent, and as human activity increases, plus the fact that the climate's starting to warm, this could be a bigger issue in the future. And not only bringing like non-native species to the continent, but potentially also transporting them and native species to different sites within the continent. So that kind of could create the same kind of problems when you're starting to see competition from species that haven't ever been there before. Cumulative impacts. So over time, of course, the impacts can start to build up. So maybe one person visiting one penguin colony won't have much of an impact, but if one person visits every single day, it can start to add up. So that's the same with science and tourism. Sadly, cumulative impacts is not something that we have a lot of data for or kind of a comprehensive understanding of in the peninsula or really anywhere in the continent. So we've kind of got to work with what we know. So there is a kind of an increasing interest and pressure from Antarctic treaty parties for managing or regulating tourism, given that it's kind of growing so rapidly. So there's been a whole bunch of working and information papers submitted to the treaty over recent years. And so they've proposed kind of a bunch of recommendations or solutions, but nothing's been agreed upon yet. So that brings us to this project, systematic conservation planning. So I guess the idea was conceived because there's like growing human activity and an obvious need for kind of thinking about management of the region to ensure that biodiversity is protected into the future and also that tourism and science can coexist and continue. So the aim of the project is to develop a spatial conservation plan for the entire peninsula that incorporates science, tourism, plants and animals, so all of our biodiversity, and climate change if possible. So we're focusing only on the terrestrial environment, and that's mainly because the marine environment is kind of outside the scope of this project. That would be, doing both together would be a massive undertaking as they're quite different and they involve different stakeholders. So we're focusing on the terrestrial for now. Potentially the marine environment could be done in the future. So I'm going to give you an overview of the systematic conservation planning method. Just a quick one. More detail can be found in the attached PDF. So I encourage you to have a look at that prior to our online discussion if you're not quite sure about things or you kind of want to have a more comprehensive understanding. So I'll just go through the basic steps of kind of systematic conservation planning with you. You start by kind of identifying your region, which we've done, the Antarctic Peninsula, and then defining planning units in the region. So in this case, in this example, each planning unit is equal to a 1 kilometre squared cell. So each of those little squares is a planning unit. We then need to identify stakeholders, which of course we have already done as well. We can identify 3 primary stakeholders for the region: biodiversity, science, and tourism. So we then want zones that kind of represent these stakeholders. So in this case, it's quite simple because we're just doing 1 zone per stakeholder, but you could in theory have kind of mixed matches between them as well. So to explain the zoning kind of process, I'll give you an example. This is the Great Barrier Reef Marine Park in Queensland. What they did is they kind of used systematic conservation planning to designate a whole bunch of different zones where in each of the zones different activities can take place. So in the light blue zone, that is where commercial ships and things like that can go. So those vessels cannot go into any of the other zones. And then the green zone is only for biodiversity, so that's like our protected areas. Of course, you can go in there with permits and things as well, but there's no fishing, no big ships. The yellow zones are science zones, so kind of they're a bit less protected than the protected areas, but again, you can't undertake fishing or anything else in there. And then the blue zones are kind of the more recreation zones. So no commercial fishing, but you can do recreational fishing or jet skiing or snorkeling, scuba diving, and anything else like that. So that's kind of like an idea of how zoning could be used. So in the peninsula, we could have zones for biodiversity, science and tourism. So the next step of the project, which is what we're doing now, is stakeholder engagement. So this kind of consists of a few different things, but in general, you want to talk to each of your stakeholders to see what their objectives and aims are for the region and what they value and kind of what do they need to kind of continue what they're doing successfully. From a biodiversity perspective, of course, that would be like looking at each species to see what they need and how much. So to do the stakeholder engagement we've had a bunch of different things. We were lucky enough to visit some sites with hurtigruten and quark, which was really great. It wasn't like a comprehensive visit to the peninsula, but it kind of gave us a better understanding about how tourism works there and also to understand what the peninsula looks like and how it's different to the rest of the continent. We've had conversations with stakeholders and we'll continue to have those as we kind of progress with this part of the engagement. There'll be surveys and then of course our online workshops. And we also had an in-person workshop with the tourism operators in February this year, which was lucky that we could get that in time. So the next step in the process, and the one that's really important, is identifying features of value to each of the stakeholders. So in the peninsula, that might be things like penguin colonies, rich vegetation, scientific infrastructure, historic sites, tourist landing sites, geological formations, glaciers, things like that. Effectively, the reason that you would visit a specific planning unit or site. So, and this is what our online discussion session is going to be about. There's a bit more information in the values introduction video, which you can hopefully watch next. So the next stage after we've identified our features of value is to define a target for each feature. Now, the targets for each feature are probably going to be different for different zones. So, for example, rich vegetation patches, which is obviously really important to biodiversity and quite important to science, may be of zero interest to tourism. So they don't need to their target for that feature would be zero. So the idea behind targets is that you set them for each feature and in each zone. So they kind of represent how much of the feature the stakeholders determine is necessary to be in each zone. And so necessary kind of corresponds to the objective of the zone and the stakeholder. So for biodiversity, we'd say that we want it, that feature to persist into the future indefinitely. So how many Gentoo penguin colonies need to be in the biodiversity zone to ensure that it will continue into the future? Now, each of these targets is often determined by stakeholders and experts, especially when quantitative data doesn't exist, which is one of the problems, of course, with the peninsula for most features. That's one of the reasons we're undertaking stakeholder engagement. But of course, another is to make sure that the systematic conservation plan will work with all of the stakeholders. So one of the online surveys will be about setting targets, so we will revisit that later and kind of provide more information then. So the next step in the process is after you've kind of identified all your features and set targets for them, is you feed all of your data into PrioritizeR, which is a conservation planning software. It's in the open source programming and language and environment R. Well, your problem or PrioritizeR's aim is that you want to allocate enough planning units to each of the zones to meet and achieve all of your targets. So that's the problem that you're trying to solve. And on top of that, you want to do this for the least cost. Now, I talk about cost in the attached PDFs, but we won't kind of visit it here. So how does PrioritizeR do this? So in the most basic scenario, so a scenario where we haven't given PrioritizeR any additional constraints or penalties. So thus, PrioritizeR will keep allocating planning units to different zones until it's met all of its targets. So how does it do this? Well, it starts by generating a random solution to the problem that meets all of the targets. So it allocates some planning units to the biodiversity zone, they're the ones in green, some to the tourism zone, the pink, and some to the science zone in blue. And so kind of randomly allocate planning units to zones until it's met all of the targets. Then it does this again, and then again, and maybe hundreds or thousands of times, and it keeps doing this until it converges on the optimal solution. Now, how does it know when it's optimal? The optimal solution is the one that meets all of the targets for the least cost. So that's how it kind of prioritizes solutions. Now, you can repeat this process for lots of different scenarios. So maybe, for example, you might lock a specific feature into a certain zone. So maybe our current aspers could be locked into the biodiversity zone, which means prioritizer has to put those planning units into that zone. So what do the results look like? In table format, they would look something like this for our basic scenario. So you can see on the left, that's your target that you've assigned. So our feature is ACBR1. For the science zone, we've assigned it 0.004%. And on the right, it tells you how much prioritizer has allocated to that zone in the solution. And so it's met the target. So spatially, this is what we might expect the results to look like. So this just shows the very tip of the Antarctic Peninsula, and this is a very basic scenario, so there's no kind of additional requirements or constraints. So you can see green biodiversity, blue is science, and pink is tourism. So this is just some initial kind of runs I did last year, just to kind of test prioritizer and see how the data went. Now, in this more advanced scenario, we've set a whole lot of different constraints. So we've locked in aspers to the biodiversity zone. We've also increased connectivity to make sure that biodiversity areas are closer together, because that's important. And we've increased some of the targets for tourism. So you can start to see quite differently from the basic scenario that prioritizer has grouped all the biodiversity planning units into some bigger zones. And then there's tourism and science sites scattered throughout the rest of the peninsula. So that's kind of what the results might look like. So we've got our spatial maps allocating everything to different zones, and we've identified areas that are important for biodiversity, science, and tourism. So how will they be used? Well, hopefully they can be used as a decision support tool, so guidance for both IATO and the Antarctic Treaty Consultative Meetings. And therefore help direct site management on the ground and ensure that everyone's values are maintained into the future. Now, of course, what we will do is we will consider many different scenarios when we're kind of using prioritizer, so we can present a whole range of scenarios to IATO and the ATCM. What we do recognise, of course, and what I think we all agree on, is that it's really important that we can kind of set aside biodiversity areas to ensure that all of terrestrial Antarctic biodiversity can persist into the future. And this kind of aligns with other aims of the ATCM and kind of scientists and policymakers to better develop the protected area network in Antarctica. Of course, kind of prioritizer cannot make a decision for us, so it's only a decision support tool, and that's how it can be used to guide. So why are you being asked to be involved in this process? Well, conservation plans are only viable if they are developed in conjunction with feedback from all stakeholders, and biodiversity, scientists and policymakers are all very important stakeholders in the Antarctic Peninsula region, and you are the experts. So the scientists that know biodiversity really well and of course know what science wants, as well as policymakers. You've got all the kind of information that we need to help make this project successful. It's also your chance to give input into the process, to feed directly into this method. So please give us lots of feedback and tell us what you need. So the next steps in the stakeholder engagement are participating in the online discussion session. So hopefully this will only be an hour, and that will be about identifying our features of value for both science and biodiversity. So there's a short introduction video just on values, which it'd be great if you can watch beforehand. We'll then just finalize all of those values on an online platform, Slack. I'll talk about that later. And that will just kind of enable us to finalize across sessions, seeing as we're running multiple online discussion sessions. There will then be 2 online surveys that will ask you to fill in, and I'll give you more information about those later. So, thank you for tuning in, and I look forward to seeing you soon in our online discussions.